Hello, we are back in chapter 1. Now we're going to learn how to solve quadratic equations. And quadratic equations are the type that usually look like trinomials or binomials, but their highest power would be a second power. So something like where a and b and c are just real numbers, ax squared plus bx plus c equals 0. That's an example of it. Or not an example, but that's kind of the form they take. So something like 3x squared plus 7x plus 2 equals 0. So that the techniques that we had in the previous section, there's no way that we can solve this with those techniques. So we're going to have to come up with some new ones. But I think we've already talked about one of them in a previous section. It was kind of a spoiler. Let's see. We would use a lot of times if the polynomial or the quadratic on the left of this equation factors, we would use the zero product property that we talked about before, where you want to write it as something, two factors. See if this trinomial here factors, and then set each factor equal to 0. This one, whatever it is, equals 0, and this one equals 0. And then you'd solve those separately. So I think we've kind of seen some of this before. So it'll be a little review, but then a lot of it will be new. So, okay, let's just first talk more explicitly about what a quadratic equation is. Here's the definition of a quadratic equation. A quadratic equation in x, in other words, that's your variable they want to specify, as opposed to y or z or anything else, is an equation that can be written in the standard form, ax squared plus bx plus c is equal to 0. So notice too that they say can be written in standard form. So that way, if the terms are all mixed up, like the one above, it was 3x plus 2 equals negative 7x, that's still technically going to be a quadratic equation, even though it doesn't look like it. They're saying it can be written in standard form. So I can move, some terms around to make it look more like the standard form. So that's what they mean. It doesn't have to look like this right off the bat. As long as there's an x squared term, then it's probably going to be quadratic. And then also, I think we've spelled this out yet in this class, but the difference between an equation and a expression. Equations have equal signs, so we can solve them. We can solve. So when you see any kind of equation, quadratic or linear, or any kind of equation, we're able to solve it, and that's usually what they ask us to do. But sometimes, like in the very first few sections we did in this class, you have an expression. Expressions have no equal signs, Oh, I shouldn't be plural. There's usually only one equal sign, if anything. So cannot be solved. Only simplified. So if you see, sometimes it seems like the math problem that you do will say simplify this, and some will say solve this. But that's the difference, is if it has an equal sign, you're able to solve it, like these ones down here, this guy and this guy. But if it's just an expression, then you're not able to solve it. The best you can do is simplify it. So I guess like in that factoring section that we did previously, you can factor like if it was just the quadratic part of this problem, this example that I wrote, that you would just simplify or factor. Simplify, in other words, factor. But if as soon as I throw in an equal sign, equal to whatever, but I'll put 0 just to make it simple, then you can solve. So that's kind of the difference. If you see them say solve or simplify, that's why sometimes we say one, sometimes we say the other. Okay. We might have said that before, but I can't remember. So the quadratic equations have this form, ax squared plus bx plus c equals 0. And then just like in this example that I wrote here, a, b, and c are just real numbers. So in that example, a is 3 because that's the coefficient of x. B is 7, or sorry, 3 because that's the coefficient of x squared. B is 7, that's the coefficient of x. And then c is 2, that would be your constant term. All right, okay, back to it. With a not equal to 0, because if a was equal to 0, then this term would just disappear. It'd be 0x squared, which is 0, and you'd only be left with the bx plus c equals 0, and that would be linear. So they're saying that a cannot be 0, or else this wouldn't be quadratic at all. You need a to be not 0. If a is 0, it's a linear equation, and we know how to solve that from the previous section. A quadratic equation in X is also called a second degree polynomial equation in X. Second degree because that's the highest power you see. So in the previous section, we saw linear equations. The highest power was 1. Here, the highest power is going to be 2. And then we'll have to see in future sections if there's an exponent of 3 or higher, what to do then. But usually you don't see too high of an exponent in math classes anyway. So here's that zero product property or principle that we've had to use it before, but now we're really going to get kind of more deep into it. The zero product property or principle, whatever. I think I called it property before. Some books call it one thing, some books call it another. Property, yeah. Okay, so to solve quadratic equations by factoring, we apply the zero product principle, which states that if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So if A times B is equal to 0, then either A or B is equal to 0. So I think we've spelled that out before, but that was kind of what allowed us to solve quadratic equations before. I think something like, let's say you had something simple. The one I wrote on the previous page was kind of more complicated. This guy can factor. That's an easy trinomial method. You're just looking to see what multiplies to make 3, but adds up to 4. Okay, that would be 3 and 1, or 1 and 3, whatever order you want to put them in. And I'd set each factor equal to 0 separately. And that's because I think we mentioned before, if I have 3 things adding together or subtracting, and they add up to 0, I can't really say much about any of those numbers. That x squared is some number, 4x is some number, 3 is obviously 3, a number. They add up to 0. That doesn't mean I can say x has to be 0, or there's nothing I can really say about that. But as soon as I write that sum, in other words, addition, as a property, or sorry, as a product of multiplication, now if it comes down to 2 things being multiplied. Capital A represents this first factor. Capital B represents the second factor. Their product is equal to 0. If you have 2 numbers multiplying to equal 0, there's no way that both of them cannot be 0. It has to be, it's like if A, B equals 0, then A is 0 or B is 0. It has to be that way. So that's kind of the reasoning why we factor. It takes a sum or difference of things and makes it a product, and we can finally say something about each of the individual pieces of the product, whereas we couldn't say that before about sums or differences. All right, so now they're going to really spell it out. This is how we do it. Because we know we need to use this property somehow, this zero product property or zero product principle, as they call it in this book. But how do we go about it? At one point do we start using it? So, okay, we got these are the steps to solving it. And I think once you do a few of these, you probably never have to look at these steps again. You'll just kind of memorize them. First step, okay, if necessary, rewrite the equation in standard form ax squared plus bx plus c equals 0. In other words, by moving all non-zero terms to one side, thereby obtaining 0 on the other side. So if you had some of the terms on one side and some of the terms on the other, just move them all to one side so that 0's on the opposite side. And then I guess also make sure that your terms are in descending order of powers. It has to be highest power on the left, just like with factoring. When we saw these types of things, we always made sure that the highest power is on the left and then descending order from there. Okay, once you have that, you should try to factor completely. In this section, everything should factor. We'll see in the future what to do if what's on the left side, these quadratic guys, don't factor. Should always factor in these problems. In this section anyway. Yeah, like I said, this is section 1.6. But in the future sections, we'll see what to do if it doesn't factor. There's other techniques we can use. But once you factor, kind of like we mentioned, we're going to apply the zero product property or principle, setting each factor containing a variable equal to 0. So notice they said setting each factor containing a variable equal to 0. That means if let's say you factored something and you had just a number out front, say it was 2 times x plus 3 and then x minus 4 or something like that. So if you had that, that's technically the product of 3 things. You've got 2 and then x plus 3, x minus 4. Those are 3 factors, but the 2 in front, he has no variable, so he's not going to produce any kind of solution. You'd only have to take each factor that contains a variable and set each one equal to 0. So that's kind of what they mean by that. The 2 is not going to, nothing's going to happen there. I could try to set him equal to 0. but that's not going to happen. Never. 2 is never equal to 0, no matter what. So it's kind of the reasoning behind it. We don't see that too often, but when you see it, just anything that's numerical with no variable, just ignore it as soon as you factor it. It's the factors that contain x or the variable that matter. All right, then once you do that, you're going to solve the equations in step 3. So in other words, just do some simple kind of arithmetic to solve now they should be linear equations now that you've factored it fully. And then once you're done, check the solutions in the original equation. As long as you did all the steps right, those should work, the solutions, but I guess you're just checking to make sure you didn't make any mistakes. All right, now this guy, 2x squared plus x is equal to 1. I want to follow those steps. The first step was to make sure it's in that standard form, and it looks like this one is not. I need to move all the terms to one side of the equation. I already have 2x squared and x on the left side. I guess I might as well bring the 1 over to the left side as well. 2x squared plus x, and then I've got that -1 is going over there as well. And now it's equal to 0 because the 1 and the -1 add up to 0. Okay, now it's in standard form. We've done step 1. Now step 2 is to try to factor it. And this one, unfortunately, this trinomial on the left side, we're going to need that kind of complicated factoring technique. That's the because it's a trinomial, 2x squared plus 1, or sorry, plus x minus 1. But it has a leading coefficient other than 1. So I'm going to need to factor it over here and do a little bit of work. This is good review, maybe. This is one of the harder factoring techniques. If you remember, what we're supposed to do is multiply a times c, the leading coefficient multiplied by the constant. 2 times -1 makes -2. So that's the number that goes up here. And then that middle coefficient b, which is the coefficient of x, which is 1 in this case, needs to go down here. Now I'm looking for numbers that multiply to make this number at the top AC, but add up to the number at the bottom 1. What two numbers have product, or in other words, they multiply to make -2, but sum, in other words, add to +1. All right, I got to think about that. That would be 2 and -1, I think, because 2 multiplied by -1 is -2, and then 2 plus -1 is +1. So those would be our winners. Let's see, I'm going to put, what do we got? I'm going to put the answers here, 2 and -1. And I think we mentioned when we did the factoring section back in chapter P, that it doesn't matter what order those are in. I put the 2 on the left and the -1 on the right. But if you had done it the other way, -1 on the left and 2 on the right, that would be fine as well. Yeah, it doesn't really matter. The process might look a little different, but then from there, it'll by the end, it'll look the same. I'm going to rewrite the first term and rewrite the last term. They stay the same. But then the middle term is going to break into 2 terms, each of which have the coefficients that we wrote over there. So this guy was just an x, but now it's going to be a plus 2x and a minus 1x. Let's see, might as well, yeah, there we go. Which, like we said before, I just rewrote it in a different way. The 2x and the -1x add up to this x. So I didn't really change the trinomial. I just kind of split it up. I kind of made it look messier, which seems like it's not helpful, but it will be helpful. Because at this point, if I did everything right, this should factor by grouping. And then we'll be good to go, and we can go back to the original problem where we're actually trying to solve an equation. Factored by grouping, there we go. All right, so between the first and the second terms, I can factor a 2x out. I'm gonna go ahead and do that. They both have a 2 in common and they both have an x in common. If I take 2x out, let's see, 2x multiplied by what would give me this first term? I would need an x. 2x times x would be 2x squared. And then 2x times what would be 2x? I'd need a 1. Okay, now I kind of ignore the first 2 terms and focus on the third and the fourth term. Between -1x and -1, it looks like -1 is what they have in common. And then the check, remember, one little tiny subtle thing about factor by grouping is that middle sign that's between the third and the fourth term, it should match here as well from this step to this step. And it does in this case, but I should always check that. All right, -1 multiplied by what would be -1x? Okay, x. -1 multiplied by what would be -1? I thought about putting -1, but a -1 times a -1 would make a +1, but that's not what I want. So this actually has to be positive. And then that means that I think I'm doing something right here because I've got x plus 1 is the same between them. I can factor that out of both of these big terms. Again, you're thinking of this guy as one big term, and this is one big term. If I take this one's x plus 1 away, 2x is left. And if I take this one's x plus 1 away, minus 1 or negative 1 is left. So we've kind of gone off to the side and factored it. We had to do that. And at this point, if you had written these two numbers in a different order, instead of 2x and then minus 1x, if you had switched it and wrote minus 1x and then 2x, that would have been fine. Your answer just would have been the opposite factors. It would have been 2x minus 1 on the left and x plus 1 on the right. But either way, you're going to get the same answer. So it doesn't really matter what order these factors are in, as long as I have the plus 1 with the x and the minus 1 with the 2x. There we go. So a lot of times the factoring technique is simple enough to where you could just kind of do it here, boom, boom, and no need to go off to the side and do work. But this trinomial method with the leading coefficient being not 1, that's the one that's, I always hope that one doesn't come up. Okay, how about now? The next step was, once you factor it, you're going to set each of those factors equal to 0. And they said at least each factor that has a variable. In this case, we only have 2 factors and both have a variable. So I just set them both equal to 0. And now I'm going to try to solve each one. So the one on the left, I'll subtract 1 from both sides. Okay, it looks like I get negative 1 as an answer. So there's one of my solutions. And then the other guy, I need to do a little more work. In order to solve this little equation here, I need to first move the 1 over by adding it. I'll be left with 2x is equal to 1. Okay. And then I'll divide both sides by 2. There we go. All right, so x should be equal to 1/2 in that case. Okay. X is 1/2. So I have 2 solutions to this equation. And then the fourth step is supposed to be, I'm going to check my answer. But to be honest with you, if this is a midterm, I'd probably check my answer because it matters. You know, a midterm or a final, it's worth a lot of points. So I want to check my answer. But if it's just homework, I don't know. You have a lot of attempts. You can try the homework over and over again. You can keep clicking on try similar problem, and then it'll give you a similar problem, and you can get the points back. So it's not that big a deal to get it wrong, you know, on the, yeah. So, but if it's on the midterm, I'll probably do it. Anyway, let's check this guy first, sure. So you have to check one at a time. You can't check them both together. That's one of my solutions. The very first one I got was negative 1. So I'm going to take the original equation, 2x squared plus x equals 1, and replace any x that was in there with negative 1. So, okay, negative 1 is going to go for the x squared, and it's going to go for this x as well. There we go. So we got to be careful here. We got to use order of operations. I've got negative 1 squared. I have to do that first. Okay, so maybe this should have been talked about earlier. Should be order of operations. Okay. The first thing you should do if you're just given an expression and you're trying to simplify it, like this, the left side of this equation, I've got some exponents, I've got some parentheses, I've got some multiplying, you know, there's a certain order it has to be done in, or else you'll get the wrong answer. Parentheses, or brackets. Sometimes in certain problems, they'll use brackets. Like if this was written 2 times negative 1 with a bracket squared plus bracket. Anyway, think of brackets and parentheses. They're the same thing. Yeah, no need to really differentiate between them. But either way, if there's something to be done inside parentheses, then we'll do it. But in this case, there's nothing to do inside the parentheses. There are parentheses, but they're kind of only there to separate the 2 and the negative 1 to the second power, kind of. So that one, there's kind of nothing to do as far as that goes. Sometimes there's, excuse me, there are things multiplying inside the parentheses or adding. Then I would go ahead and do that if that's the case. Next thing to do would be exponents. Anytime you see an exponent, that has to happen before anything else. And I do have that happening here. The negative 1 to the second power, that's the new thing. Negative 1 times negative 1 is positive 1. I'm going to write that. So definitely, it would have made this problem incorrect if I would have multiplied the 2 by the negative 1 and then raised it to the power. That wouldn't work. All right. So I had to do the negative 1 to the second power first. All right, now what? Now, the next thing would be the next step. After you've taken care of all your exponents, The next one is M/D for PEMDAS stands for multiply or divide. Multiply slash divide. That'll be my next step. And then I kind of scan my problem here. Do I have any multiplying or dividing I need to do between here? Yes, that 2 is being multiplied by the 1, so I better do that next. It's gonna not look as nice, but I'm gonna move it over here. 2 times 1, oops, is 2. So this is kind of becoming just 2, and then that -1 is still there, equals 1. Okay, and then lastly, this should be where it's pretty simple. You need to add or subtract anything that's in common. And subtract, okay. So that's all that's left to do here on the left side. 2 subtract 1 is 1. So it looks like this is a true statement. 1 on the left is equal to 1 on the right. Check. So that means I probably got at least this solution is correct. I've done everything right on the left side of this, but I should check the other solution. See, you can see how long this takes. Oh, and I'm so not looking forward to substituting a 1/2 in for x. Oh my gosh. Lord. But I'll try to do the same thing. Follow the order of operations. Ew, a 1/2 is going in there. And I'm just replacing in the very original equation that they gave me, the x. Let's see, x was 1/2. All right, 1/2, you go there, you go there. All right, all done. Now we try to simplify that. Same kind of thing. I need to first look inside the parentheses. Okay, is there anything to do inside the parentheses? No, there's only a number, a half. There's nothing adding or subtracting or anything interesting. So I can move on to the next step. It's exponent. There is an exponent. 1/2 to the second power. I'm gonna think about that. If you know what you're doing, then you don't have to even write that out. That's 1/2 times 1/2, which is 1 times 1 in the numerator is 1. So I can go ahead and write that numerator. And then 2 times 2 in the denominator is 4. It's okay. Taking care of the exponent, 2 times 1, 4. And definitely don't, these, it's very, 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 very tempting to cancel the 2's. Let's see. Where are they? This guy, this 2 and this 2 cannot interact because of this square. It's like, that's kind of holding them back from interacting with each other. That 1/2 has to be raised to the second power first. And now that 2 can probably interact with that fraction. And the parentheses for this 1/2, they weren't really there for any reason. I'm just going to remove them. There's nothing needing to be distributed or no exponent. Okay, now I can do the multiplying, which in fractions is more like reducing and then multiplying. I'm going to put this whole number 2 over 1, and then I see I can cancel on the diagonal. I've got 1 over 1 times 2 is 2 plus, and then this 1/2 that's left. And now I think it's pretty clear. I did the multiplying, and now I can add or subtract. 1/2 plus 1/2 is 2 halves, or in other words, 1, and that's true. 1 is equal to 1. Okay, we must have done this right. Those two solutions, x equals, what was it, -1 and x equals 1/2 are correct. All right, so far so good here. Now, I shouldn't, wow, why did I squeeze all that into one little area when I had plenty of room over there? Well, hopefully you didn't try to squeeze it in. I'm sorry. Oh, and oh my gosh, and I had an area to check too. Wow. Why'd I squeeze it all in? I don't know. Just for funsies, I gotta keep that in mind. Okay. All right. So now let's see, another way to solve quadratic equations when they're not too complicated is using the square root property. So these would be used if you were given something squared equals something. So I guess usually instead of ax squared plus bx plus c equals 0, what if there was no middle term? Like the b was 0, if it just looked like ax squared plus c equals 0. You could probably solve it by factoring, but the square root property, when it's applicable, is actually a lot easier and nicer. So that's what we're talking about here. Let's see, quadratic equations of the form something squared equals something, u squared equals d, where u is an algebraic expression and d is a non-zero real number, can be solved by the square root property. If u is an algebraic expression, in other words, it's just maybe the sum or difference of a variable term and a non-variable term, and then d is a non-zero number, then u squared equals d has exactly 2 solutions. If u squared equals d, then u equals the square root of d, or u equals negative square root of d. But it's kind of, if you're actually doing the math, let's say, I know they're trying to keep it really general here. U could be anything, d could be anything. If I was given this and I was trying to solve for u, whatever u is, solve. for you, I would say, well, really all I need to do is get rid of that square. What's the opposite of squaring something or raising it to the second power? It would be square rooting both sides. That's kind of what you're doing. But if you square root both sides of an equation, the part with the variable, which I'm assuming is the left side, I think, it does have the root and the square cancel, but on the right side, you have to put a plus or a minus next to your numerical part. And when I say numerical part, I just mean the part that has no variable. Place a plus or minus next to the number node, or I would say non-variable side of the equation. That's all. But so that's just a different way to write it. They're saying when I say plus or minus, that means I have two solutions all of a sudden, one positive and one negative. So a positive square root of d, whatever that is, that's a solution, and then negative square root of d, that's another solution. And they kind of wrote it more like we kind of showed up here. They say equivalently, if u squared is equal to d, then u is equal to plus or minus the square root of d. I guess the only downside of writing it that way, the way kind of I wrote it here and the way they wrote it here, is students might forget what that means. Plus or minus, it doesn't mean there's one solution and it might be negative, it might be positive. That means there's two solutions, one's positive and one's negative. But just don't forget what it means, and then you'll be good. So this is a lot easier. Let's actually try to solve this equation. So this one, I'm going to try to, excuse me, isolate the x squared term. Then use that square root property. Use the square root property. And really this one, I could solve this the same way that the very first example did. It said, get it in standard form and then factor. I think this should factor, but this is a good way to do it, or an easier way to do it if you're missing the x term. Because yeah, like we mentioned before, notice that you see the ax squared term, but there is no x term. That guy's gone. So it's really just looking like ax squared plus c equals 0. And that's a lot simpler to solve, mostly because there's only one x term. There's only an x in one term and not in another term. All right, I'm going to try to isolate x squared. Let's see, subtract 45 from both sides. There we go. Then I have 5x squared is equal to, now 0 and negative 45 obviously is negative 45. And now I'm going to, I don't quite have the x squared, I shouldn't say x squared term, I should say x squared, isolate x squared. Because right now I have the whole term isolated, but I actually want to get rid of that 5. So yeah, I would say change that from x squared term to just x squared. If I divide both sides by 5, these 5s cancel. And on the right side, I've got negative 45 divided by 5 would be negative 9. Okay, and then this shows me, I think I'm going to take a square root of both sides, and I'm going to get an imaginary number, or two imaginary numbers, which means that I wouldn't have gotten, this wouldn't have factored. So actually that factoring technique from above, from the first example, wouldn't have worked, because I think we would have had a sum of squares, which doesn't factor it. So anyway, I'm going to use the square root property now. That means I take the square root of both sides, boom, boom, but I have to remember the plus or minus next to the side that has no variable, whichever side is just a number. On the left side, the square root and the square cancel, just be left with the x, and then is equal to, I've got plus or minus. Now we saw in section 1.4 how to deal with these guys, the square root of negative 9, and this is really why. If you need for your major to take a lot of math classes, you might see imaginary numbers again, but for the most part, this is the only useful part, is just to simplify. If you get solutions like this that are imaginary, now we know how to deal with them. I think what we did was we said, if you have a negative inside a square root, I can kind of get rid of it, but I have to kind of compensate by putting an I next to it. The I kind of encompasses the imaginary part, or the negative root. All right, that looks good. Now that I have the square root of 9 with no negative, I know how to simplify that. The square root of 9 is 3, and I've got an I. So there it is. And that's really represents, even though it looks like one solution, that's two solutions. I think in the homework, they'll ask you to write them separately. They'll say, okay, give me the two solutions separated by a comma. So I'd write one of them, just the positive guy maybe first. It doesn't matter what order they're in, and then the negative guy. So really, yeah, there are two solutions. So, and you'll get really good at this. This is, at first, it's kind of complicated, but, you'll get there. Let's see, the next topic. Oh, this is one of almost every student's least favorite things in the whole world. So I'd say this, we didn't used to even teach this in this class, but I think it's very helpful, especially when we get to chapter 7. We might use it, or actually we might use it in chapter 3 again. Used in chapter 3, but definitely chapter 7. Chapter 7. Yeah, and then sometime, let's see, I think in one of the semesters of calculus, you'll see this again. So it's something that's not super fun, but it's important for certain things. Okay. Anyway, completing the square. So if x squared plus bx is a binomial, then by adding the special number, whatever the coefficient of x was, b over 2, you take that coefficient of x, divide it by 2, and then square it, which is the square of half the coefficient of x, a perfect square trinomial will result. That is blah. So that sounds complicated and confusing, but let's see if I can just come up with an example. Like this, here we go. So I think the idea is it's kind of hard. Let's see, it's hard to solve for x when you have an x running around in this term and this term, both. So what I'd like to do is be able to write this as maybe the same factor twice, x plus something, question mark, squared. So I guess ideally I would see this fact, there'd be a special number that goes here. We don't really know what it is yet, but there's a special number that goes here to where I can factor it, the trinomial. Once I put that number there, it'll be a trinomial. I can factor it, and both factors are the exact same thing, so I can write it as something squared. And that's a lot easier to solve. I can use the zero product property to solve that. And using this to solve equations, it's almost overkill. This is a technique that's so complicated. We have easier techniques to solve equations. This is probably not too useful for that, but in the future, it'll be useful to find, for example, we're going to learn how to graph a circle. It's going to be useful for figuring out where the center of the circle is. And there's no other way to do that than this process here. So right now, it seems like, why are we doing this way? Solving equations it's easier than this. Why we're using this hard technique. But anyway, it'll be useful later. In this example that we have here, I'm just gonna, it takes some getting used to, but what we do is say, okay, the perfect number that's gonna go here to make this factor into a perfect square, as they say. In other words, two factors that are the same. It's gonna be half of the coefficient of x, which was 6, or as they wrote it here, they just say, put it over 2 and then square it. And that, once you get good at this, that'll be just occurring in your head. You're gonna say, okay, the coefficient of x is 6. What's half of that? It's 3. What's that to the second power? And you'll just write it. So that's kind of in my imagination, I'm thinking about that. 6 over 2 is 3. Squared is 9. Okay, so that must be the perfect number I want to put here. And then the whole thing should factor in a nice way because it's designed that way. So if we think about that one, if I were to factor that, that's a trinomial with leading coefficient 1. So I should be able to factor it the easy way. I'm just looking for what are the two numbers that multiply to make 9 and add up to 6. Well, the two numbers that multiply to make 9 and add up to 6 would be 3 and 3, because 3 times 3 is 9, and 3 plus 3 is 6. But lo and behold, those are the same trinomial, x plus 3, x plus 3. So I could write it as x plus 3 to the second power. And then all of a sudden, there's only one, kind of like one factor, and it looks simpler. And yeah, there are some reasons we'll need it in the future. It's hard to trust it right now. So that's kind of all it is. It's just mostly the main thing is memorizing this little, I don't know if you even call it a formula, this thing right here. That would be something that you probably want to write on your note card for the first midterm. Yeah, the number that you need to complete the square, if you have ax squared plus bx, is b over 2 to the second power. That's the key, yeah. I think if you remember that, the rest is pretty good. As soon as you insert that b over 2 squared, then you can see how it factors and yeah. All right, so now that just tells us how to complete the square, but now we're going to actually use that to solve an equation. But like I mentioned, I would say that this technique is kind of silly to solve this equation. We have easier ways to solve this equation, but we just want to see it in action for practice. That's all. So I want to solve this by completing the square. Okay. First thing to do, actually, we don't have steps outlined. because at a certain point, you're going to want to insert that b over 2 squared quantity, but not quite yet. I would say isolate the x squared, and I should just say isolate the variable terms. Okay. So I guess the thing about this trinomial here is if I were trying to solve this the way we did the first example, I would say, oh, okay, maybe it factors into two binomials. Then I'd say, what two numbers multiply to make -1 but add up to 4? Oh, there are no numbers like that. So that's the problem, I guess. This is another technique in order to solve this if it doesn't factor. So what I need to do now is it's kind of like that one, maybe the one is the problem. If that one were a different number, then this might factor. So I'm kind of just, it's almost like I wish it looked differently, so I'm going to make it that way. I'm going to move one over and bring in a number that I think would actually be nice and it would factor nicely. It's kind of like when people are coming over to my house, I just throw all my my stuff in the closet and hope they don't look in the closet, if that makes sense. Yeah. You would be better if you were a different number. Let me just move you over there so you're not a problem anymore. And then I'll insert a number that I like. That's the idea. All right. So I moved him over. Yeah, it'll work out okay. He's over there in the closet or whatever, just so no guests see the mess I make. All right, now I'm gonna try to get that perfect square number. Let's see. Next step. Once I isolate the variable terms, I'm gonna add the quantity b over 2 squared, the one that was described on the previous page. But the only thing is I have to add it to both sides of the equation because it's like an equation is like scales. I can't just put something new on one side of the scale and hope that it balances. I'd have to put the same quantity on both sides in order for this equation to be balanced. But really, I just want to see that b over 2 squared here on this side, but I have to put it over here as well just to balance it out. Okay, add the quantity to both sides of the equation. The equation. Okay. So that's either you could do it in your head or you can kind of write it out onto the side. Not that they asked about a, but the coefficient of x is a, that's 1. B is the coefficient of x squared is a, that's 1. And then the coefficient of x is 4, that's b. And then c is -1, I guess, here, but that doesn't matter. Now I need to figure out what is this quantity I need to put here. It's b over 2 squared. All right. Feel free to just do that in your head also. B is 4, so it really comes down to 4 over 2 squared. 4 divided by 2 is just 2, and if I square 2, I got 4. So that's I think I used to call it a magic number. That's kind of our magic number that we need to add to both sides. I'm going to put that here, add it over here, and then add it over here. This, 4 is kind of a special number. When b is 4, this magic number that you need to add to both sides will also be 4. But that won't always be true. If b is anything else, then that magic number b over 2 squared will not be the same. 4 just happens to have that property where half of itself squared is itself. Half of 4 is 2, square that, you get 4 back. All right, now, the whole point of that, like we kind of saw on the previous page of this thing, is the left side should factor the left side. It should factor into a perfect square, as they call it. Because like we saw on the previous page, it should be x plus something squared. Whatever, depending on what b was and what your magic number is, it'll be something. As long as there's some number there. Or minus, it could be a minus. I should put that. In this case, we'll get a plus, but sometimes it's a minus, and that's okay. So, okay, the left side of that, I don't really need to memorize anything new at this point. Just really that b over 2 squared is the new thing. Other than that, it's all the same thing we've done before. I'm going to factor this. This should be, let's see, I need two numbers that multiply to make 4, but add up to 4. I think that would be 2 and 2, right? 2 times 2 is 4. 2 plus 2 is 4. And then that, since it's the same binomial twice, I can write it as that guy squared. All right, and then the right side, it's pretty clear what to do there. I've got 1 plus 4. I can just go ahead and add those. So maybe I should say simplify the right side of the equation. right side. Yeah, in other words, it's just going to be two numbers. You might as well add them together. 1 plus 4 makes 5. So it comes down to x plus 2 squared equals 5. Then I kind of ran out of room for these steps, but there's one more step. Now we're going to use the zero product property to solve fully. Use the zero product property to solve. Okay. At this point, it should be just looking like something squared equals something. I can get rid of that square. That's the next thing I need to do. I need to square root both sides. Boom, 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 boom. But don't forget, when you square root both sides, the portion that's just numerical that has no x has a plus or minus. On the left side, the square root and the square will cancel. I'm left with x plus 2 by itself. And now on the right side, it's not just the square root of 5, it's the plus or minus the square root of 5. So there are really two solutions here. But in this case, this is a little more complicated than the previous example. I need to subtract 2 to the other side. And then I'll have x isolated. So these answers are going to look weird, but hey, that's how these problems are. X is, you can put the plus or minus 5 root first and then the minus 2, or you could do, you're probably more likely to see the whole number that's not in a root on the left side, and then the number that's in a root on the right side, but they're either way is the same thing. But don't forget that that represents two different solutions. So if the homework says, okay, I need you to write each solution separately separated by a comma, I know that this really means -2 plus the square root of 5 and -2 minus the square root of 5. So notice that the sign of 2 is not changing. This plus or minus only saying that the sign in front of the square root of 5 is changing. It's plus in one case, it's minus in the other case, but there's no, no need to change anybody else's sign. So there's your two solutions. And if the square root of 5 had, if 5 actually had a square root, I would just simplify that, but 5 has no square root, so that's about as good as they get. Yeah, so I'd say completing the square, that kind of is like you're pulling out the big guns to solve an equation that can't be solved with smaller, I don't know, more simple techniques. If this thing factored in the beginning, x squared plus 4x minus 1, I could have just did the zero product property like we did with the first example, but this is what we have to do for the more complicated guys like this. Okay. So you might have seen this formula before in a previous class. I feel like most students, when they get to community college, they've at least seen this before. The quadratic formula. So this is where usually as a student, I would say, okay, if I can just use this formula here, -b plus or minus the square root of b squared minus 4ac over 2a. If I could just use that to solve this equation, why bother with completing the square? Because it's true, I could have, when I had that previous one, x squared plus 4x minus 1 equals 0. When I was trying to solve that, I could have just used the quadratic formula. A is the coefficient of x squared, that's 1. B is the coefficient of x, which is 4. And C is the constant term, -1. I could have just replaced all these A's, B's, and C's with these numbers, and I could have got the same thing. But I think the thing is the completing the square idea. It's helpful, like I said, for someday we're going to need to find the center of a circle by looking at its equation, and we have to complete the square. And then also finding a certain special thing about the graph of a parabola. We're going to need it. But the other thing is, it's kind of actually interesting. This is the determining factor if you're a math nerd or not, if you think this is interesting. The way that someone came up with this formula is they took this ax squared plus bx plus c, and they completed the square on that thing. So I'm gonna show you that real quick, just because it's interesting and it's kind of makes you appreciate the quadratic formula. So that's, I think someone a long time ago, very smart, much smarter than me, they said, it seems like this is like the steps that we do when we complete the square to solve an equation, it's like an algorithm. I take b over 2 and square it, and then I add it to both sides. And I know the value of b changes every time, but it just seems like there's not a lot of creativity or brain power needed. I can probably program a computer to do this for me, obviously. So maybe what if I just complete the square on this very general looking equation, ax squared plus bx plus c? Could I just do that? And that's what someone did. They said, all right, here's I'm going to pretend like in my head, A and B and C are just real numbers, okay? Pretend. Oh, the first step that we said for completing the square was complete the square. So you don't have to memorize this, okay? It's not, yeah, it's not going to be on the midterm or anything like that. But it's interesting. It makes you appreciate the formula, and it's kind of cool. I'm a nerd, so I used to actually just do this for fun when I was bored when I was a student. That's really sad. The first step anyway was I need to move the constant term over to the right side. You want to, I think we said above on the previous page, isolate the variable term. So I'm going to subtract c from both sides. That way the ax squared and the bx are together on one side, and then the negative c is now on the other side. Okay. And then the next step was I need to complete the square. Oh, this is hard. I need to go. You know what? And the other thing too was we didn't have an A on the previous example. Does that matter? Yeah. I need to divide everyone by A. A. Everybody gets an A. All right. Because I think before, yeah, we had just x squared plus blah, blah, blah. That's going to be weird. Even it looks weird, but B and A are just real numbers in my mind. I'm trying to remember that. Equals negative c over A. And that's just some kind of real number as well. All right. Now I'm going to complete the square, which sounds crazy. I'm going to find that special number. Half of that squared, right? That's what we're supposed to add to both sides. And I got to think about that. Now it's not half of B, but it's B over A. So that's kind of weird. B over A over 2. That's kind of like a complex fraction I have there. B over A squared, or sorry, B over A, and that's over 2. It kind of comes down to B over A. I'm dividing by 2, really, because I want to simplify this. If I divide by a fraction, that means I'm really multiplying by its reciprocal. That becomes B over A multiplied by, instead of 2 over 1, 1 over 2. Okay, let me multiply across there, and then I'll raise it to the second power. B times 1 in the numerator is just B. In the denominator, I have A times 2, which is 2A. And I'll raise that to the second power. Okay. B squared over, now I have to square the 2, which will give me 4. And I have to square the A, which will give me A squared. So this is very, very weird, but this is such a general equation. That's what I have to add to both sides in order to complete the square on this general quadratic equation with no specific A, B, and C. So I'm going to go back and take my x squared, my B over AX and all that, and add that quantity to both sides. X squared plus B over AX plus, I'm going to leave some room for that quantity I wrote. And then there was a negative C over A plus, and again, I have to add that quantity to both sides now. This thing is kind of getting in the way here. There we go. All right. Now that number we just found, well, it doesn't look like a number, but I'm thinking of A and B are just some numbers. So B squared over 4A squared is just some number also. That has to be added to both sides of my equation. 4A squared, B squared over 4A squared. Okay. Now, the left side should be able to be factored into a perfect square trinomial. X plus something squared. Okay. And I think they even spelled it out on the previous page what it's going to be. Where'd it go? Or 2 pages away. It's B over 2. So once you add that kind of magic number to both sides, you can write it as a perfect square trinomial. It's going to be x plus or minus B over 2 to the second power. So in this really general case, it's this thing over 2, this guy. So B over A over 2, which we actually kind of simplified a little earlier. Let's see, I should highlight this so we can see where it came from. That was this. B over A and that over 2. I could kind of reinvent the wheel, but I kind of already did that here. This before I squared it. I don't want to square it because that's not what I have inside the parentheses. B over A over 2, I kind of wrote it here as division, and then it became multiplication. Here we go. That's what we need. B over A over 2 is actually B over 2A. I'm going to rewrite it that way because that's a lot nicer. Let's see. Parentheses x plus B over 2A, that's squared equals. Now these two terms, it doesn't look like it, but they're supposed to be just numbers. A, B, and C are all just numbers. In order to combine those into one fraction, which would be nice, I'm going to have to find a common denominator. between these guys, the common denominator would be 4a squared. So the rightmost fraction, the one that's highlighted in yellow, it already has the perfect denominator. I need to multiply the leftmost fraction by 4a in order for it to have the same denominator, because that 4a times the a that's already there would make the 4a squared. Okay, now this numerator, negative 4ac, and this numerator can now combine in one fraction, 4ac plus b squared. They're definitely not like terms, so I can't really combine them. But that's, I can at least write it as one fraction over that common denominator of 4a squared. Okay, and I think, and it looks fine, but I think for it to match the quadratic formula, they make it look a little nicer by just bringing the positive term, the b squared, on the left side, and then the minus 4ac on the right side over 4a squared. And now what we're trying to do is solve for x, even though it looks like all these are variables, a, b, c, and x, but we're thinking of b and a and c are all just numbers, but x is a variable. So now I'm going to go like we did before when we actually had concrete numbers. I'm going to square root both sides, use the zero product property, or not the zero product property, the square root property. I square root both sides of the equation. It doesn't look like it, but the right side is just a number. So I'm putting the plus or minus there. The left side, the square root and the square cancel, so I'm just left with the, I'm gonna have to move this over. What was inside the parentheses, I'm gonna move it over here. X plus b over 2a, that's the left side. The right side now has plus or minus the square root of, now it's gonna be in my best interest to, if you have the square root of a fraction, you can give the numerator its own square root and the denominator its own square root. And the reason that's a good idea in this case is because 4a squared, the denominator actually has a square root. So I have hope of simplifying the denominator, but the numerator I can't simplify. Let's see, maybe before we do anything, I'll do that. 2a equals, okay, because you can think of this as the square root of 4 times the square root of a squared, and both of those can be simplified. The numerator, there's not really any hope for him. Sorry, buddy. And then over, okay, the square root of 4 is 2. The square root of a squared is a. Well, that's kind of as good as that's going to look. And then to finish this off, I'm trying to isolate x. So this guy's kind of in the way. If I move him over, then I've solved for x. And it's a positive b over 2a. I'm going to subtract him, minus b over 2a. Oh, minus b over 2a. So now x is all by himself. X equals, I have negative b over 2a. And then I have plus or minus this thing, plus or minus the square root of b squared minus 4ac over 2a. And we just kind of got lucky in a way that these two fractions have the same denominator. I can put them together, negative b plus or minus the square root of b squared minus 4ac over 2a. And that's the quadratic formula. So it seems like, oh, the quadratic formula is so much easier. Why would you ever complete the square? Well, someone completed the square to get the quadratic formula. So really, the quadratic formula isn't this magical thing. It's just, it saves us time, but yeah, it came from completing the square. Anyway, if you think that's kind of cool, then you're probably a nerd like me. But if you already fast forwarded this, you're not even listening anyway. So, but like I said, you don't need to know this. This is just kind of, to me, I think it's interesting. You'll see that the higher you go in math, the more you'll see things explained like that. Why are things the way they are? Because we kind of care. I don't know. Most students don't care, but some do. So I'm going to even write that down. Not on the midterm. Don't even worry about that. Don't worry. Not on the midterm. It might be a problem like this. This is possibly on the homework, or definitely on the homework, possibly on the midterm. Possibly this type of problem on the midterm. But the whole thing I wrote where we derived the quadratic formula, don't worry about that. So here's an equation. Maybe it can be factored to solve it, maybe not. But definitely the quadratic formula always works. So it's, yeah, I would say it's kind of like factoring would be nice. I would say if there's an equation and it can be factored, that's probably easier. But if it cannot be factored, the quadratic formula and completing the square will always work. So I might just go ahead and go for that. Let's see. What are we doing again? Oh, yeah. We look at it, we identify A, B, and C. If you kind of don't feel too comfortable, I'd probably write it out. A is 2, because a is the coefficient of x squared. In this case, b is the same number, just happen to be the coefficient of x and the coefficient of x squared are the same. And then c is -1, the constant term. But now I just need to take the quadratic formula and just plug those in. And yeah, on our midterm, you can have a 3x5 note card with whatever you want on there. If you want, you can put the quadratic formula on there. But some people memorize it without even trying to. You kind of use it so many times that, I don't know, you just memorize it. But maybe not. Oh, what is happening with this thing? Oh my gosh. So for me, it kind of helps me to draw or write, I'm sorry, write it's kind of the skeleton of the quadratic formula. X is equal to negative something plus or minus the square root of something squared minus 4 times something else. That's A times C over 2 times A. I usually just, it helps me to rewrite the quadratic formula, but leaving empty parentheses where there were A's, B's, and or C's. And then I'll kind of fill them in. Okay, like, so we said A is 2. Let me look at the quadratic formula. Where's an A? There's an A next to the 4 and also an A next to the 2. I'll replace those. And then, yeah, if this is kind of new to you, then it's probably good to write it carefully like this. But if you've done this before, you don't really have to be this careful if you don't want to. Oh, wait, I'm not supposed to replace it with A. I'm supposed to replace it with 2. Oh, my God. That was the whole point of rewriting it. A is 2. Come on. What? Why is that disappearing? All right, next one, B. What is B again? Another 2. Usually A, B, and C are different numbers, but in this case, they're trying to mess with us. B is 2. You're everywhere. B, you're here and you're here. So I'm going to put a 2 here and a 2 here because that's what B was. Okay. So far, not so bad. 2, 2. And I make sure I put everything in parentheses because if A, B, or C is a negative, then it's kind of, it makes it tricky because parentheses kind of make sure that negative numbers behave the way they're supposed to behave. All right, now I'm going to take C, which is -1, and replace it. There's only one place C occurs in this formula, and he's right there. But he's important still. You're important, little C. Don't worry. You matter. -1. Okay. Now I'll simplify that. -2. Okay. Plus or minus the square root of. We got 2 squared. 2 times 2 is 4. Minus, and I can multiply these together. Well, actually, it's kind of like, I got to be a little careful. It's a negative multiplied by a positive multiplied by a negative. That's 2 negatives, which actually makes it positive. And then it's 4 times 2 times 1, which is 8. Good stuff. Over, and then I've got 2 times 2 in the denominator, that's 4. So -2 plus or minus. Inside the square root, I need to add those first. I can't square root 4 and 8 separately. I have to add those. It's almost like the square root acts like parentheses. Parentheses have to be taken care of first before anything else. So 4 plus 8, that's 12. And then over 4. Okay. Now this, maybe the square root can be simplified, maybe not. In this case, we can simplify it. Luckily, we saw a little bit of that in section 1.4. The square root of 12, I can write 12 as 4 times 3. And that's advantageous to me because the square root of 4 actually has a square root. So that's a good idea. Okay. Just simplifying this kind of takes a while. The -2 and the, okay, and this is what I want to say. I really want to simplify or reduce this -2 and this 4. But when you have a fraction whose numerator or denominator has more than one term, you would have to reduce all the terms. So I have to kind of wait and see if this square root of 12 is going to have a 2 pop out, and then I can reduce. All 3 terms have to be reduced at the same time. It couldn't be just a couple terms. So that's why I keep having to work on this before I reduce in order. So you can write this in your notes if you want, but you don't have to if you think you'll remember it. In order to reduce all 3 terms would need to have that common factor. So that's the problem. I see 2, yeah, and 4, they both have the same divisor, but 12, he's stuck inside the root. I'm going to see if I can get something out of him to escape the root, and then maybe I can reduce. Because they'd all 3 have to have something involving the reducing factor. And I think it's going to work because this square root of 4 is going to be a 2. Then I have square root of 3. The denominator is 4. Okay, now it's going to work. They all have to reduce together. It's going to have to be like, what goes into all 3 of these numbers? 2, 2, and 4. Well, 2 goes into all of them. This will become a -1. This 2 will become a 1, and this 4 will become a 2. And I think that's pretty much it. Let's see. It's going to be -1 plus or minus. I could write 1 times the square root of 3, but we know that 1 times anything is that thing. So probably the simpler way to write it would be -1 plus or minus the square root of 3 over 2. And that's it. I'd say that's a perfect answer on the midterm or final or whatever. But on the homework, if they want the answers separate for homework, that's because that really what I circled there represents 2 answers, right? One's positive and one's negative. In the homework, I would say choose either the positive or the negative. Let's say positive. Rewrite it with just the plus and not the minus. And then rewrite it with the minus and not the plus. There we go. So that's either one. If you wrote that on the midterm, that's fine. That's fine, or that's fine. But homework, I think they want you to separate the 2 solutions like that. It's a lot of work just to make it look nice, right? And I know some may be thinking, I could just put that in my calculator. Why? That was -1 plus the square root of 3 over 2. I kind of figured that out as a decimal, but as soon as you put the square root of 3 in your calculator, it's an approximation. It's not exact anymore. So these are exact answers. They're exactly right. Perfect, perfect, perfect. But as soon as you put it in your calculator, it's almost perfect. It's close, but it's not quite, because the square root of 3 is decimal, goes on forever. It never stops. But if you put it in your calculator, you're rounding it. Anyway, in math, we like exact answers. There we go. Oh my God, why do I try to shove all this information into one page when I have another page ready? Oh, I don't know what my problem is. Anyway, what do we got? Now we got the discriminant. That's kind of a new topic here. This is, okay, don't worry. I think the difficult stuff in this section is done. Now it's the simple stuff. So the idea behind the discriminant and why we even give it a name is when you look at the quadratic formula, the solutions could be nice fractions or whole numbers. They could be, let's see, your outcomes of using the quadratic formula are solutions are either one of these options, either whole numbers or fractions, which is nice. That's yeah, we'll say when that happens. Or it could be that they're real numbers with a square root. That's what we ended up with in the last problem. Let's see, yeah, it was way back there. But we had a square root of 3 stuck in there. So that's kind of what we ended up with. And then the last option is imaginary numbers. We haven't seen that yet in this section, but that could happen. And that would happen if what's inside your square root ends up being negative. If b squared minus 4ac ends up being a negative number, then you're going to have imaginary numbers. So that's kind of why, to figure out which of these 3 you're going to have in the end, it's all about what's in that square root. Because if whatever b squared minus 4ac is, if it's a nice number that has a square root, you're going to end up with the whole answer is a fraction or a whole number. If b squared minus 4ac is a positive number, but it doesn't have a square root, you'll end up with what we had in the previous problem, where it's a real number, but it has a root. And then the last option is if what's inside the square root, b squared minus 4ac, is negative, then you're going to see imaginary numbers as solutions. So, okay, so we actually give that thing a name, b squared minus 4ac, since he's what determines whether you have whole number answers, fraction answers, real answers with roots, or imaginary numbers. He's called the discriminant. The discriminant is that quantity which appears under the radical sign in the quadratic formula. The discriminant of the quadratic equation determines the number and type of solutions. All right, so now they're spelling it out. What are you going to get? If the discriminant is positive, in other words, b squared minus 4ac is greater than 0, because greater than 0 is just another way to say positive, there will be 2 unequal real solutions. So that's kind of what we had in that last example. Like in the previous example, I think we ended up, what was it, -1 plus or minus the square root of 3 over 2. Those are 2 solutions, -1 plus the square root of 3 over 2, -1 minus the square root of 3 over 2. Those are 2 real solutions, real as in not imaginary, because there's no negative number in the root, but they're not the same number. One having a plus and one having a minus is going to make them different. That's an option. That happened in the previous example. But it could also be that the discriminant is 0. That doesn't happen too often, but if b squared minus 4ac happens to add or subtract to make 0, then there's only one real repeated solution. Maybe we'll see an example of that. And then the last option is if the discriminant is negative, like we said. In other words, another way to say negative is that thing is less than 0. B squared minus 4ac less than 0. Then there are two imaginary solutions. Now let's see, there are times where maybe you don't really care about the actual answers. You're just kind of curious, what kind of answers? Are we going to get real answers or imaginary answers? What kind and how many? So for this one, let's compute the discriminant and then we'll determine the number and type of solutions. That means we don't really care what the solutions are. I just want to know, are they real or are they imaginary? And are you getting two different solutions or just one repeated solution? So that's all I need to do is figure out what is this discriminant, whether it's positive, negative, or 0. That would tell me what I want to know. B squared minus 4 times A times C. Okay. B is -7. There's B. And he's going to go here. Negative. I was going to write B in there. Supposed to replace it. B is -7. And then I've got minus 4 times A. In this case, A is 2. A equals 2 times C. And C, don't forget the negative also. C is not just 4. It's -4. So I'll kind of simplify that, see if it's a positive number or a negative number, and then that'll tell me what's going on. -7 squared, that's -7 times -7, which is 49. Then I've got minus 4 times 2 times -4. That's a negative times a negative, which is a positive. 4 times 2 times 4 is, let's see, 8 times 4, 32. At this point, I kind of already know it's going to be positive. I have a positive number plus a positive number. Is that 81? I think so. Anyway, that number doesn't really matter. All that matters is that's positive. Or in other words, 81 is bigger than 0. So that means that 2x squared minus 7x minus 4 equals 0 has, I think it's two unique solutions, right? Or in other words, two unequal real solutions. Yeah, that's what it was. It has two unequal, but that's the same. That means the same thing as unique. Unequal, unique, real solutions. Real is opposed to imaginary. So that's really all I wanted to know, that how many solutions does it have and what kind are they, real or imaginary? Yeah, so that's kind of that's it. And then if that number it was negative, I would have said there are two unequal imaginary solutions. If that number was 0, then I would say there are two equal or repeated real solutions. Yeah, all right. And now we got an application, which is always fun. Is that the last example? I think that's it. Oh, wait, no, one more, sorry. Application, okay, what do we got? So here's a formula, P equals negative, there's no negative. P equals, what the heck is wrong with me? 0.01 A squared plus 0.05 A plus 107, and models a woman's normal systolic blood pressure, P, at age A. Use this formula to find the age to the nearest year of a woman whose normal systolic blood pressure is 115. Well, in that case, it looks like they're giving us a woman's normal systolic blood pressure being 115. And so that's either going to be one of the variables or the other. It's either P or A, but I think P was the normal blood pressure, right? A was the age. So I'm going to take that equation they gave me and replace P with 115. And then I'll solve for A. Solve for A. I wish they would have given me A. That would have been a lot easier to solve, but no. But then I wouldn't have had to use the quadratic formula, and it wouldn't even have been in this section. So just rewriting their equation or their formula they gave me, but replacing P with the value that they gave 115. But everything else is staying the same. I need to solve this for A. Good thing we got the handy dandy quadratic formula. Can you imagine trying to complete the square on this thing? Oh my gosh. That'd be B squared, B over 2, ew, 0.05 over 2 squared, terrible. So I think we'll probably use the quadratic formula. Yeah, that sounds good. But I do notice there's something wrong with this guy. You can only use the quadratic formula if your equation is in standard form, ax squared plus bx plus c, and 0 is all by himself on the other side. I need to get this 115. He needs to get in the mix with all his friends over here. Yeah, you need 0 on the other side, or else it's kind of like part of C would be missing because 107 is not C. It's supposed to be 107 combined with this 115. They make C together. Yeah, so that's kind of a subtle thing that maybe wasn't pointed out. Now now everybody's on the same side. 0 equals the A squared, and the A term didn't change. They're still the same as they were. What's 107 minus 115? Negative. Oh, why did I put an equal sign? Oh my gosh. Losing it. I think it's -8. Let's see. Or -8 minus 8, whatever. That's it. Huh, okay. Now I should be able to say what A, B, and C are. Oh, yeah, this is confusing because the variable's A. But if you want to, you could just rewrite this with an X instead of A, and then you're solving for X. But A represents the age of this person. And then lowercase a, though, that's just representing the coefficient of my variable. Little b is the coefficient of the variable to the 1 power. And then c is the constant term here. Don't forget your negative. All right. I think now that I've identified those, I can plop them into the quadratic formula. Let's see. Don't worry, if you don't memorize the quadratic formula, that's no big deal. You can, like I said, for a midterm, you can write it on your note card. For your quizzes and your homeworks, you could just look at it in your notes or whatever. So I was about to write the quadratic formula usually has x equals negative b, blah, 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 blah. But in this one, I have a is equal to, because that's my variable, negative b plus or minus the square root of b squared minus 4ac over 2a. All right. Kind of like with the last example, I'm going to try to just rewrite the whole thing, but wherever there was a little a, little b, little c, I'm going to put parentheses and fill them in later. I think this kind of helps me not make mistakes when I do this. So, okay, first of all, I got little a is 0.01. Where does he occur? Only right next to the 4 and right next to the 2 on the bottom. So I'm going to put a 0.01 in those spots. Let's see. I didn't leave a lot of room. 0.01, 0.01. Okay. We're definitely going to need a calculator on this one. I don't think this is something I can do in my head. And then what else? Little b is 0.05. Where is b in the formula? Right in the front and right inside the square root. So you're going to be replaced with 0.05, my friend. 0.05, 0.05. All right, C, you're last. Where are you going to go? He only occurs once in the quadratic formula. Sorry, dude. You're important too, don't worry. C is -8. He's going to go right there. There'll be a lot of calculator stuff going on. -8. All right. Now that I have all the numbers in front of me, I don't need to see all that stuff anymore. Let's see. Let's see if I can kind of start working on this, whittling away at this thing. -0.05 plus or minus the square root of. I'm going to go ahead and square this, and I'm going to use my calculator because I'm not that good. Plus, maybe I'm not awake enough. 0.05 times itself, or 0.05 to the second power is 0.0025. And next, I'm going to do -4 multiplied by 0.01 multiplied by -8. It's a negative times a negative, so it's actually going to be a big positive number. I'll do 4 times 0.01 times 8. 4 times 0.01 times 8, you get 0.34, or sorry, 0.32 over. Now in the denominator, 2 multiplied by 0.01 is 0.02. There's going to be a lot of calculator stuff here. Oh, man. No wonder I left so many pages of room for this example. -0.05 plus or minus the square root of. Now we're going to add those guys together. 0.3225. The numbers in the parentheses. So I definitely, like we said before, I cannot square root them individually. I can't say, what's the square root of 0.0025? Write that down, add it with the square root of point. No, I have to add them together first and then take the square root over 0.02. Oh, man. Is this ever going to end? 0.05 plus or minus. Now, I have no hope of trying to do that in my head. And I think I mentioned before, this is when it's an application, I think they expect rounded answers or decimal answers. Don't worry about, I always say we prefer exact answers. We don't want to see decimals. But this is a real life situation, you know, they want to see rounded answers. If they want to know what is it about what age is a woman whose normal blood pressure is blah, they don't need an exact age, like the exact day of the year, but they just need, oh, she's about this many years old. Let's see. The square root of 0.3225 after I've talked too much is 0.5. About, depends where you want to round. I think it's best to keep as many decimal points accuracy as possible until you're all the way done over 0.02. Excuse me, this is where I'm gonna have to split this into two solutions now because I can't take this negative 0.05 and add it and subtract it with this number at the same time. It's got to be done separately. This is where it looked good as one big kind of answer, but now I'm going to have to remember that this is really two answers. It's negative 0.05 plus that big decimal number, blah, 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 blah. And then over that denominator, 0.02. And the other one is, I can write that exact same thing, but with a minus between the two numerator terms. And not to put these in my calculator separately. I'm going to just, I'll just work on the left one first. I'm going to combine those things in the numerator, don't forget the negative 0.05 added with 0.567890835. Okay, I get 0.51, wait, yeah, 0.51 something something. I need to divide that now by 0.02. So this whole thing, after I'm done adding these and dividing by 0.02 is about 25.89. If it's in the homework, they'll probably tell you where to round it. I'm going to kind of box that answer. Now it's time for this answer. Negative 0.05. Now we're subtracting 0.567890835. I got this numerator something like negative 0.61 da 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 da. But I'm just going to go ahead and take that number and divide it while it's sitting on my calculator by 0.02. I got negative 30.89 if I round it to two decimal places. But they'll tell you where to round if you need to. But since this is a real life scenario, I should think about what did this represent? Oh yeah, the age of a woman who had that 115 blood pressure. But when I think about it, how can this be someone's age? Did they age backwards? This was before they were born, 30 years before they were born. No, this doesn't make sense in this real life context. If this problem was if they just gave us that equation to solve with no context, I would keep both of these solutions. But this doesn't make sense, does it? I should say negative age doesn't make sense. I don't think so. I don't think doctor asks, okay, what age would a woman be? And then you say negative 30 years old. They'll probably slap whoever they're talking to. Get out of here with that. Doesn't make any sense. So this must be it. It's between about 25 or 26 years old. Women. I think was it women or just, I can't remember if it was women or men or both, have blood pressure 115. I think it was it women? Man, we started this problem so long ago, I forgot. Oh yeah. Excuse me, a woman. There we go. There we go. Yeah, that wouldn't make any sense. Negative 30 years old. What the heck? Anyway. All right, okay, I promise. This is the last problem. This seems like a lot. This section is heavy. This is a long video, and I'm sorry about that. I'm sorry that all semester you're gonna have to hear me talking. Oh my God. I hear myself talk on videos on my phone, and I'm like, I almost want to throw up. That's what I sound like. So I'm sorry. What do we got? Here we go. So this one, the Pythagorean theorem, this one you see it all in math, like almost every semester you're going to see this guy for different reasons. Definitely in trigonometry. Trigonometry and the Pythagorean theorem go together like peanut butter and jelly or something like that. Okay. So if you have a triangle, which seems kind of random, okay, I don't have any triangles at home, but sure, whatever. And you care about the lengths of the sides, but it has to be a right triangle, which means that one of the angles is 90 degrees. Right triangle, 90 degrees. Okay. Yeah, one angle. If you have that, then there's a relationship between the lengths of their sides, whatever the three side lengths are. And when you take you square each of them, square all the side lengths, the two shorter ones added together add up to the square of the hypotenuse, which is the longest side. You can think of it as the longest side, or it's the one across from the 90-degree angle. Yeah. So that way, if you know, maybe you know two of the lengths and you don't know the third one, you can always find it using that formula, which is exactly what we're gonna do now. Isn't that exciting? This is kind of cool, right? This figure shows the dimensions of an old TV screen. What is the size of the screen? And because usually when they tell you the size of a screen, they're giving you the diagonal length, right? This is a blah, blah, blah inch TV screen. They're not telling you the height or the width, they're telling you the diagonal length. So that's what we want to find out, even though usually you're given that, but that's fine. We're going to pretend like this could happen in real life and I might actually care. Pretend, okay? Just use your imagination like when you were a kid. So it looks like which one's the hypotenuse? It's the longest side or the side across from the 90-degree angle. I'm kind of focusing on the bottom triangle, but you could also do the top triangle because they're really the same triangle. It doesn't matter. But C is the hypotenuse. That's the one we're looking for. What C is what we don't know. Question mark. But B and A we know. And actually B and A doesn't matter which one's which. You could say, like here, I could say, oh, 25.6. I'm going to make that my B. You can make that your A, and I'm going to make my 19.2A. Doesn't matter, it's going to end up with the same answer anyway. As long as C is the correct guy. C has to be the hypotenuse, the one across from the 90-degree angle. Yeah, which is what we don't know, so I'll keep that as is. It's going to be something squared plus something squared is equal to C squared. Because I don't know C, I can't replace it. A in this problem is 19.2, it looks like 19.2. But yeah, if you had called the horizontal length 25.6, that was A. You know, it doesn't matter, it'll end up being the same. I said B was 25.6, but if you said that was the 19 point whatever, that's fine. Excuse me, I need to raise B, each of those to the second power. 19.2 multiplied by itself is 368.64. 368.64. Now I'm going to add that with this guy. And definitely using order of operations here, I need to kind of simplify each of these exponents first before I add. I cannot add 19.2 and 25.6 and then square. It has to be that order of operations. Anything in parentheses first, there's nothing to do there. And then exponent, and then multiply, divide, and then add, subtract. Yeah. All right, and then 25.6 times itself, or raised to the second power, is going to be 655.36. And that's equal to the thing I don't know, C squared. Now I can add these together. That's really all there is left. So 655.36 plus 368.64. I get this left side is exactly 1,024. That's crazy. That doesn't sound right, but yeah, I think it is. And now I can solve for C by square rooting both sides. Nice, use the square root property, square root u. But remember the numerical side, or the side with the actual number, not a variable, has to have a plus or minus. Let's see, on the right side though, the square root and the square just cancel. So C is going to be equal to whatever we get here. I think it does have a square root. 32, look at that. So C is 32 and negative 32, but since this is a real life scenario, I'm going to stop and think, does a negative number make sense here? No. I don't think you're going to sell a lot of TVs if someone says, hey, I'm here to buy a TV, and you say, yeah, I've got a negative 32-inch TV over here. You're going to say, what the heck? They're going to say, I'm going to go to a different store. This is nuts. This is the one. Yeah, that doesn't make sense. You can't have negative length. That doesn't make sense. Negative length or negative age, like in the last example, makes no sense. But again, if this problem had no context, it was just solve this or find the other side of the, actually, as long as it's a triangle, if you can't have a negative length of a triangle, it doesn't matter if it's a television or what. So yeah, no matter what, it doesn't make any sense in this example. Okay, it must be 32 inches, right? Yeah, inches. Feet, that would be nuts. That would be like a movie theater, huh? Okay, so this TV must have been 32 inches diagonal, not diameter, diagonal. Oh my gosh. Yeah, that was fun, you guys.